In this video for section 3.4, we're going to talk about something called the rational zero theorem. And the rational zero theorem allows us to make a list of all possible rational zeros of a polynomial function. Rational zeros means that they're either whole numbers or fractions, but they don't have square roots in them. And the way that we make this list is we list the possible factors of the constant term that goes in the numerator of the fraction. Possible factors of the leading coefficient goes in the denominator. And then we go through and make all possible combinations between those two lists of numbers. Now these are possible rational zeros, so not all of them are actually going to be zeros. But in order to be a zero for a polynomial function, it needs to be on this list. So we're going to look at example 1. It says list all possible rational zeros of f of x equals negative x to the fourth plus 3x squared plus 4. So we start with factors of the constant term. And the constant term here is 4. So we want to think of numbers that multiply to equal 4. Well, 4 times 1 and 2 times 2. Now when we're listing the factors, we have to remember that they could be either positive or negative, because to multiply to positive 4, it could be 4 times 1, or it could be negative 4 times negative 1. We don't know. So any factor that we list, we have to list it both in positive and negative. And the book is going to do that using the plus or minus sign. So our possible factors are plus or minus 1, plus or minus 2, and plus or minus 4. Those are all the ways we multiply to equal 4. Then in the denominator, I'm listing factors of the leading coefficient. So the leading coefficient here is negative 1. And so how do I multiply to get a number that equals negative 1? Well, the only way would be negative 1 times 1 or 1 times negative 1. So my two factors are plus or minus 1. So it really doesn't matter if the number is positive or negative, because for each of your possible factors, you're going to list a plus or minus in front of the number. So now we're going to go through and list all of the possible combinations. So we have plus or minus 1 over plus or minus 1. That could result in plus or minus 1. 1 divided by 1 is 1. And then depending on the signs we have, it could end up being positive or negative. We have plus or minus 2 over plus or minus 1. That would result in plus or minus 2. And we have plus or minus 4 over plus or minus 1. That would result in plus or minus 4. So these are my 6 possible rational zeros: plus or minus 1, plus or minus 2, and plus or minus 4. So next you should look at checkpoint problem number 1. Do this in your notes, check your answer, and then move on with the video. So next we're going to look at example 2. So for this one, my factors of my constant term here is negative 2. So we're going to put factors of negative 2 in the numerator. My leading coefficient is 15. So factors of 15 would go in the denominator. So how do I multiply to get negative 2 or 2? Well, it needs to be 2 times 1 is the only way. So plus or minus 1 and plus or minus 2. Those are my two options. Factors of 15, well, I know I could do 15 times 1, or I could do 3 times 5. So all of my possible factors are 1, 3, 5, and 15. So now I'm going to go through and list all of the combinations. We could have 1 over 1, that's 1. We could have 2 over 1, that's 2. And it generally works better if you get kind of a system so that you don't miss any. So I usually like to go through each possibility in the numerator over the first number in the denominator, then go to the second number in the denominator and go through each possibility in the numerator. So then I have both possibilities with a denominator of 1. Now I'm going to list the possibilities with a denominator of 3. So it could be plus or minus 1/3 or plus or minus 2/3. Okay, so now I'm going to go to 5. Plus or minus 1/5, plus or minus 2/5. Now, if you get a situation where a fraction simplifies into something that you already have listed, then you don't need to count it again. So say if I had 2/10 come up here in my list, that's equal to 1/5, and so I would not list 2/10 again. So next we need to do the denominator of 15, so that would be plus or minus 1 over 15, and plus or minus 2 over 15. So those are all my possible rational zeros for this function. So next you should look at checkpoint problem number 2. Do this in your notes, check your answer, and then you can do the homework.